Hello everyone, welcome to this tutorial on data visualization using Python. In this video, we will delve into Python and explore how to create charts using a matplotlib and a Seaborn Python library. We will go step by step, explaining every line of code to ensure you understand it completely. Whether you are a beginner or an aspiring data scientist, this tutorial will help you build a strong foundation in data visualization. So let's get started. Before we jump into coding, let's understand why data visualization is essential. Data visualizations help in identifying trends and the pattern in data, communicating insights effectively, making data-driven decision, detecting anomalies and the outliers, simplifying complex dataset for better comprehension, enhancing storytelling with the data. Without proper visualizations, raw data can difficult to interpret, making it challenging to derive meaningful insights. So whether you are working in the data science, business analytics, or a research, visualization is a fundamental skills to develop. Now to create these charts, we need to install and import the required libraries. So this is my Jupyter notebook. You can also use Google Colab. Uh, just type this command uh, pip install cbone matplotlib and pandas. In my case, these libraries are already installed in my system. Now let's import the necessary libraries. Import pandas as PD for handling data. Then import matplotlib dot pyplot as pmt, and then import cbone as sns. Matplotlib provides basic plotting functionality, while Seaborn builds on it to create visual appealing statistical graphics. By combining both, we can create a professional quality visualizations. Now let's load our dataset. So for these demonstrations, we are using a census data that contain the demographic and economic data. So census underscore data equals to pd dot read underscore csv and the path of the dataset. Then display the first few rows. Census underscore data dot head function. So this dataset contains the various attributes such as the populations, income, and other census related details. So always inspect the dataset before proceeding, checking the first few rows, helping the understanding the structure of the data. So now let's create our first chart, the bar chart. So this is one of the most commonly used visualization in data analysis, as it allows us to compare different categories easily. Bar charts provide a clear way to display differences in numerical values across different groups, whether it is sales performance, population statistics, or any other categorical comparison. Bar charts are highly effective. So, a bar plot is used to compare categorical data. So, here we will visualize population distribution across different boroughs. Bar plots are widely used in the statistical analysis, business analytics, and the research to compare different categories. Alright, so let's start writing the code for our bar plot step by step. I will explain each line of code as we go. So stay with me. First, we define the figure size. So this line create a new figure with the width of the 12 inch and the height of 6 inch. So why do we do this? Well, specifying the figure size, we ensure that our chart is neither too small nor too large, making it easy to read and interpret. Always defining a good figure size help in better presentation, especially when working with multiple charts. So now that we have our figure, so let's move on plotting the actual data. We will use a seaborn sns.barplot function. This function that generates a bar plot, then x equals to borrow. This is a column name. Specify the categories that will be plotted along the x-axis. Then y equals to total POP. This is our column name, and determine the variable to be plotted on the y-axis, representing the total population of each borough. And at last, data equals to census underscore data, specify the data set we are using. So with this single line of code, we have created a bar plot, but it looks quite basic. So let's enhance it with the title and the labels. Title. So these three lines add a title to the chart and the label the axis, making it clear and more informative. Always label your charts so that anyone viewing them can easily understand the data being represented. Sometimes long text label on the x-axis overlap, making them unreadable. So to solve this, we wrote the plt.xticks rotation equals to 45. So this rotate the axis label by 45 degrees, ensuring that they are spaced out and easy to read. And finally, we need to display the chart plt.show function. So this function renders the plot and make it visible. Always call this function after plotting to ensure the visualization appears. Now let's run this code. Now that's it. We have successfully created a bar chart that shows the population distribution across different boroughs. So this type of visualization is great for the comparing categorical data and the understanding distributions pattern. Now that we have covered bar charts, let's move on our second visualizations, the histogram. Histograms are incredibly useful when we want to understand the distribution of our numerical variable. They help us see how our data is spread and whether it follows any particular pattern. So, a histogram groups continuous data into intervals called bins and they represent the frequency of values within each bins. So, this make it an excellent tool for detecting patterns, central tendencies, and the even outliers. So, in this example, we will analyze the income per capita distributions in our dataset to see how income levels are spread across different census tracts. So now let's break down the code step by step and understand what each line does. So let's first define the size of our plot. Plt dot figure x size equals to 12 and 6. So this line set up the figure size to ensure our histogram is clear and readable. The width is 12 inch and the height is 6 inch. Create the histogram using sns.histplot function. Census underscore data specify the column from our dataset that we want to plot. Then bins equals to 20. It define the number of bins, meaning our data is divided into 20 equal size in per intervals. So if we set a bin equals to 5, the histogram will have very few bars and the grouping a wide range of value together which can hide important patterns. And if we set bin equal to 100, we get too many narrow bars and making the visualizations cluttered and harder to interpret. So a good rule of thumb is to experiment with different bin size and find a balance that best represent the underlying data distributions without the losing clarity. So for example, when analyzing income levels in the city, using just 5 wins might categorize data into broad income groups, low, middle, and high. So using 100 wins might make the histogram too detailed and difficult to read. And KD equals to true. So this adds smooth density curve over the histogram, helping us visualize the probability distributions of the data more clearly. If it's set to false, the histogram will only show bars. Plt.title gives the chart a meaningful title. And the label the x-axis indicating the represented data. And the label y-axis represent the number of data points in each page. And finally, we call the plt.show function to display our histograms. So without this, the plot might not be rendered properly in some environment. So now let's run the code. And there you have it. This histogram helps you see how income per capita is distributed across our dataset. So, giving us insight into central tendencies, spread, and any potential skewness in the data. So, if the bars are concentrated towards one side, we may infer that the data is skewed in that directions. And histogram are particularly useful when analyzing income distributions, economics disparity, or cost of living variation. Now let's move on our third chart, the scatter plot. So this plot of chart help us understand this relationship between two numbers variable by plotting individual data points on a graph. So scatter plot are widely used in the data science and the analytical to observe trends, correlation, and patterns in data. So for example, if we plot income versus total population, we can analyze whether higher income level corresponding to higher or a level lower population densities. So if there is a pattern such as points forming as an upward or a downward trend, it indicates a correlation between the two variables. And if the points are scattered randomly, it means there is. So this define the figure size just like in our previous chart. Now SNS dot scatter plot function generate the scatter plot, and x equals to income. Specify that x axis represent the income of different areas, and y equals to total POP. Define the y axis represent the total population, and data equals to uses the census data dataset to extract values. Scatter plots help us identify patterns. If we see upward trends, it means higher income is associated with the higher population level, and downward trends indicate a inverse relationship, no pattern, and that means there is no significant correlation. Now these line at the title axis label to make the plot informative, just like we did in the previous chart. And finally, we use a plot dot show function to display our scatter plot. So this ensures that the chart renders properly in the Jupyter Notebook or any other Python environment. So run this code, and there you have it, a scatter plot that visually represent the relationship between the income and the total population. Scatter plots are widely used in the finance, research, and the analytics to study relationship between the different variables. So now let's move on to our next visualization, box plot. A box plot, also known as a whisker plot, is a powerful way to visualize this distribution of a dataset. It provides insights into spread, skewness, and the outliers by summarizing data with the 5T statistics: minimum, the smallest value; first quartile, the median of the lower half of the dataset; median, the middle value of the dataset; third quartile, the median of the upper half of the dataset; and maximum, the largest value. So box plot are particularly useful when comparing multiple categories, as they provide a compact summary of the data distribution. So in this example, we will examine how median income varies across different boroughs. So just like before, we define the figure size to ensure our visualization is clear and readable. Now let's plot the box plot using the Seaborn library sns.boxplot. This function generates a box plot, then x equals to borough. The x-axis represent the different boroughs. Y equals to income. The x-axis represent income for each borough. And data equals to specify the dataset we are using. Boxplot help detect outlier which appear as individual points outside the whiskers. If an area that has usually a high or low income, it will be displayed as an outlier, allowing us to quickly identify anomalies. And a title. Label to make chart easy to interpret, just like in previous chart. So always label your charts for better clarity. Since borough names can be long, we wrote them by 45 degree to improve readability. So plt dot x rotation equals to 45. So without this label might overlap, making the chart harder to read. And finally, we call the plot dot show function to display our box plot. Now let's run it, and that's it. This box plot gives us a clear summary of how income is distributed across boroughs. So if the box are long, it means the data is highly variable, and whereas shorter boxes indicate more consistency. Outliers appear as individual dots outside the whisker, representing values that are significantly higher or lower than the rest. So box plots are widely used in the finance, healthcare, and the research to analyze variable in the dataset. Now let's move on to our final visualization, which is a pie chart. So now let's create a pie chart. To create a pie chart, visualize the gender distributions in the census data. Pie charts are excellent for showing proportions and the percentage between different categories in a data sets. So here we will analyze the total number of men and women in our data set. So in this line, uh, let's calculate the total number of men and women across all census tracts by using a sum function on the respected columns. So this help us get overall distribution of gender. and we define a label for our pie chart. So this label will be used to indicate which portion of the pie represent men and which represent women. So we set up a figure size just like a previous chart to ensure the visualization is appropriately sized and readable. So since charts are circular, a square figure, so plt dot pie charts function create the pie chart. Gender underscore counts this numerical value corresponding to each category, men and women. Assign label to each sections of the pie chart, and auto pct equals to in double quotations percentage dot 1 f percent. It display a percentage inside the pie chart rounded one decimal place, and color equals to blue and pink. So set the color for the pie chart to visually distinguish between the men and women. And finally, plot.show function is used to display the pie chart. Now let's run the code. And there we have it. The pie chart gives you a clear breakdown of gender distributions in NYC census dataset. Pie charts are useful when we want to compare parts of a whole, making them a great choice for demographic analysis. I hope this tutorial was helpful. If you have any questions, feel free to ask in the comments. Thank you for watching and see you in the next tutorial.